Geographers, bonjour. Hello. I'm going to do a few videos on like starting to plan your analysis and presentation of data section and how to draw a few graphs in Excel. So I thought I'd pull this slide up just to show you kind of how important this section is in the grand scheme of things. If the project is out to 70 and we do a bit of maths, then we get 24 for the presentation and analysis section. So that is basically your graphs, any data you display on maps, your statistical tests, and your ability to kind of manipulate that data to draw the right graphs and draw maps and graphs that actually are appropriate to your study and display the data that's appropriate to your study, and then based on that analysis, then we can draw some evidence-based conclusions and for evidence-based connections. Now, so this is level 4 mark band. I've not put any of the other 1 to 3 because everybody should be aiming for level 4. 19 to 24 out of 24. And normally, if you do this well and your graphs are clear, your maps are clear, and I'm going to use this word because it's very important, and your sections of analysis are meaningful, and you manipulate the data well, and you analyze it well, then the conclusion section is an awful lot easier because you're using what you've presented and what you've analysed in this section to draw conclusions and do all these weird and wonderful things, which I'll get onto in another video. All right. So if your analysis is strong and clear and well planned and well thought out, your conclusions are more likely to follow. All right. So the first step of analysis is you're going to have, say you've done 6 or 7 fieldwork techniques. Some might have done more than that, and secondary data as well. You're going to have an awful lot of raw data, and every project will be different. So that could be in the form of like 50 questionnaires, for instance. So you can have 50 loose sheets just for your questionnaires. You could have, 30 sampling points with an environmental quality survey for each sampling point. That's another 30 sheets. So, you probably, at the end of summer or when you collect your data, you're probably going to have a stack load of loose sheets with all your data recorded on that. So the first step, before we draw any maps or graphs, is we want to actually do something with it and start this first stage of manipulation, if you like. So we're getting as head around as data. We're going to tally up certain things and put as results in tables. All right. Few here just to start you off. I've made it up. So let's pretend I did 41 questionnaires. And question 1 was, are you a visitor to Edinburgh train station, or do you live in the local area? Something along those lines. Visitor or resident. It's just a simple tally. Just go through your questionnaires, tally them up, put it in a table. That's simple. It might get a bit more complicated. If you've done some bipolar scoring, for instance, then you're going to need to think about how you lay it out. So we've got a tally for how many people have scored each score from -3 to +3. The second step is do some simple manipulation, a bit of key stage 3 maths. Work out the average score. What's the range between the lowest score and the highest score? What's the mode? What's the medium? You could even stick in, work out some percentages for certain things. You could work out a percentage for each one of these tallies. All right. Don't worry if some of these calculations are not needed. You're just starting to make sense of the data. Get your brain in gear with a bit of maths, bit of basic manipulation. Here we've done one where word cloud results. I've tallied up the number of times people have said the following words. And then at the end, I thought, well, I'll just convert 21. There's 21 like negative descriptors used by people, 19 positive. So we'll just work out the relevant percentage. Yep, easy. So you can do this for nearly all your data. Yep, I'll show a couple more examples, what I've created myself. This one just here. Quite complicated environmental quality scores. 2 different wards in Sheffield, 10 different sampling points. So it's just basically tallied it up. Yep, nice and neat and tidy, nice and organised, subheaded. First stage of analysis. You can do that for all data sets, with the exception of maybe beach profiles and annotated photos, because that would be very difficult to do, obviously. Right. In terms of drawing graphs in Excel, the key thing is you're going to need to put data in a table, and once you've done that and you've put it in a table, go to, highlight it, go to, where is it? Not that one. Insert, and then go to recommended charts. Make sure that you are using the full version of Excel, not this nonsense online version that I think is absolutely pants. So get the full version of Excel. You will get the full suite of graphs then. Click on recommended charts. Now, have a look at each type of graph. Just because it's recommended to you, it doesn't mean to say it's the right one. All right. What we got here? Clustered column chart, where we can see Edinburgh in the blue, Ayleswood in orange, and you're seeing each element of environmental quality. That's not bad. We've got a stacked column chart, which might not be the most appropriate for this. A scatter chart definitely wouldn't be appropriate. That is the wrong presentation technique for this type of data. Again, comparative bar chart. It's just the same as that. One is side on, one is just same thing, just sideways on. Again, we've got a stacked one. You need to have a look at this and think, does that actually make sense? Is the data discrete, or is it categorized, or is it continuous? And then pick one. So I'm going to go for this bad boy just here. Yeah. Click the button. Simple as that. Any good graph, especially at A-level, for heaven's sake, needs a full title, needs x-axis and y-axis labels, units. If it's not done it for you because your table's not detailed enough, then you are going to need to print it off and do that yourself. Yeah. So that'd be one. What else could we do? That's not the only graph you could use this data for. You could have a look at maybe charts. There's a stack. Radar graphs are pretty good for comparisons. What I would say is be careful about just picking the ones that look a bit fancy, because they can end up being a mess. Yeah, comparative radar graph, that's very good. You don't lose the detail. You can make analysis really good when you start writing about these. Comparative radars are good if you're doing a comparison project. So have a look. I mean, the ones, if you do decide to try and get one that looks the jazziest, just be aware it might completely be wrong. Like, just like say, I want to go. I mean, that would just be an absolute disaster. You're going to fail. Yeah, it's the wrong graph, no matter how you square it. So don't always go for the fanciest graph. Look at it and think, does that look right for the type of data set I'm trying to present? It will be a yes or a no answer. And you are going to lose marks if you pick the wrong type of graph. Right, so again, I've got pedestrian counts at different times of the day across different times of the week. Pop it in a table. Hit that, see what happens. Not bad. You can see different times of the week, and then each coloured bar is for a different time of the day, so that's not bad. That's going to make for some meaningful analysis. You can see at a glance that Saturday is the highest in every column, most number of people. Sunday's the quietest, and overall, I'd say noon has got the highest number of people at that time. So, you know, that'd be a pretty good graph to analyse. This one, not too bad. But just have a look. You will know if you come across something like that, then that is probably just bonkers. So is that. It just doesn't tell you much, really. If you're doing a transect-based study, not a comparative study, so say you are doing scores along a transect, maybe heading out of a town centre or away from a regeneration project, for instance. You want to see how multiple categories change as you move out. Highlight the box, put the data in, insert recommended charts. Could have a stacked. That's less clear, I think. Yep, so just have a little play around, have a look at multiple line for that. Yep, so just think about, is it continuous data, is it category data, is it tallied data? There's different types of data sets, and you're going, I mean, that's a disaster. Yeah, print that, you're going to get level 1 presentation basically, because it doesn't tell you anything whatsoever. It's just the wrong graph for the data set. Yep, and that is important. Try and mix your graphs up as well. So, for instance, if you decide to present one data set with a multiple radar and it's clear and it does the job, then you might have another data set for another set of data that you might want to use a bipolar bar graph for instance, or a stack bar graph. So try and mix it up a little bit. There's nothing worse than as a reader sort of reading section after section of, you know, the graphs it's the same type of graph all the way through. Yeah, it's pretty boring. Right. So, yeah, I mean, I'll put this on. I'm not going to talk you through these. Different types of graphs and ways to present data, choropleth maps, isoline maps, proportional symbols. There's a brilliant guide from the RGS where every one of these presentation techniques is in there, and there's a rationale behind it, and it'll tell you, you know, when to use the graph. So that is going to take time, and it's going to take thought, and you're going to need to read that and plan your analysis out. Right. A couple of other points I'll mention. Now, ArcGIS is online kind of web version software where you can go on and put some latitude and longitude coordinates in, add some numbers in, and it will create GIS maps. So the one you've got in front of you is a proportional circle map. Really nice and simple. The size of the circle represents a number basically. So it could be a score from 0 to 5. It could be a score from 0 to 500. You know, but the key thing is you would need, or ArcGIS will create the legend and the key for you. Yeah, because without a legend where it's telling you that this size circle represents the number 5, whereas this size circle represents the number 3, that graph is that map even is completely meaningless to the reader. Yep. So ArcGIS can do that. And I'll do a video on that as well in the future. It is free, or it was last year. If you want to do more of a kind of homemade butcher job on this, there's ways you can do it where you can handwrite it. You can do it by pen, the old-fashioned way, or use an overlay. Or you can get a base map, such as this one in Google PowerPoint, stick it in PowerPoint, and then use the draw tools and the circles to do it yourself. Not ideal, not strictly speaking a GIS map, I don't think, but if it's clear and you've got a title, you've got a legend, you've got a key, it's the right size and it's relevant and appropriate, you're still gonna score well for it. Yep, you're still presenting your data in a relevant and appropriate way. Another one, which you would have to do in PowerPoint, here's one I did earlier, like Blue Peter, is a proportional flow map. So the width of the arrows represent a number or a count. For instance, cars heading in each direction. So you stood at a roundabout and you're sort of doing counts for which direction cars are travelling, for instance. Yeah. So it's got a direction element and it's got a count element to it. So again, you must have title, legend, key, must be clear. What I've done with this is I've kind of reduced the opacity, if that's the right word, made them a bit more transparent so you can see the map underneath as well. Yep. I mean, here's an example of one I did earlier, Blue Peter style. Combinations are good for a section of meaningful analysis. Try and get away from just drawing one simple pie chart and then trying to analyse a pie chart. You're going to be struggling. You're going to have wrote 2 lines and probably come to a bit of a halt and start scratching your brain. That's because your display or your presentation, there's not enough kind of meat on the bones to get your teeth into. Yeah. So what I've done here is I've done study on 3 different wards, transects going through each ward, and I've plotted environmental quality score at different locations with a proportional circle map, and then I've transferred, for better comparison, I've done a multiple line graph for each ward, so you can really compare like which the pattern as you move away out of the city centre, but also which ward scores higher than another. Yep. Again, when you come to analyse that and start writing about it, you know you're going to have something to get your teeth into. Yep. Notice as well how figure numbers for everything. So, and they'll come in handy in a little while. If you've got figure 14, 15, 16, 17, etc. with a title, in later sections or analysis or in your conclusions, you can refer back, if you're quoting evidence, you can refer back to that graph by just saying, you know, West Ecclesfield overall has a better environmental quality than Central and Hillsborough, as seen in figure 14. And pick a number and use a bit of evidence to show that. Yep. So figure numbers as you go will make your life easier later on. What I'd say with graphs is, and this in general, it's the section where students, if they get into a tangle, they can be literally trying to draw one complicated graph and trying to figure it out for weeks on end, and they waste so much time. My advice is, if it's not happening in Excel, get the graph paper out and do it the old-fashioned way, and do it by hand and then scan it in. Right? Don't spend hours and hours and hours trying to draw one graph. Otherwise, your coursework will probably be a very stressful very stressful endeavour. What a word that is. So yeah, get the graph paper out, hand draw things. You can use overlays if you want. There's nothing to say that you have to do everything. You have to do everything electronically. Yeah. Right. Poor analysis then. Presenting irrelevant data that you didn't plan your methodology too well. You went and collected some data, you presented it because it's just there, but it doesn't help you answer your research questions. Yep. Why present it? Using the wrong graphs for the data set you're presenting. Yep. So is it continuous data? Is it discrete data? Is it categorized data, tallied data? You know, don't just pick the fanciest graph because it looks colourful and looks like something you'd never seen before, because it can end up a mess. Same token, graphs that are too simple. If you're trying to take complex data sets and you just lose a stack load of detail by just presenting an average. Yep. So you lose all this like detailed sub-data groups for buildings, traffic, open space, and you just turn that whole data set into one average and that's it, then that's not very good either. Yep. You could have one graph showing the average, but then you need other graphs showing, or maps showing, a bit more detail. So it's a balancing act. It's a balancing act between being clear and simple, but also not losing too much of the detail. Yep. Being lazy, right? Can't be asked to put a title in your work. No units, axis, no legends. So readers left to guess about what the values are for different things. That is just no excuse for it at A level. Yep. So every graph and map should have a title, should have a figure number, units and axis, and legends if needed. Other things I'll talk about a bit later on in another video, but yeah, using the wrong stats test for the data set being tested, or interpreting the stats results wrongly. Surefire way to, not hit level 4 when you do a stats test. Any stats test you do needs to be right. And then, another one, like making big and grand conclusions from like one bar graph, for instance. From what I call flimsy analysis. So you've sort of skipped the presentation and the detailed analysis bit out and just jumped to a conclusion for whatever reason. Yeah, and another thing, don't just read off your graphs and maps. For instance, there was 13 people on a Wednesday morning that went to Meadowhall, and there was 20 people that went to Rotherham bus station on a Friday at 9 a.m. God knows why they'd want to do that, but... there was 14 people that went here, 20 people went past there. That is reading off a graph. The reader can do that. Use some maths, use some manipulation to make sense of it. So, Meadowhall was 369% busier than Rotherham at the same time. Yep, you've took the numbers and you've done something with them. And those numbers can come off your graphs, they can come off your maps as well. But... manipulate the data. Yep. And I just thought I'd create a meme to end on. Alright, cheers, thanks a lot. Bye bye.